AI development is moving fast. New models and products are launching every week, but without privacy built in from the start, it's easy to create systems that are powerful and problematic. Welcome to Privacy by Design, the AI podcast. My name is Kate, your host. I'm here with Mike Logan, George Barroso, and Chris Glover. Together, they bring decades of experience in data privacy, software engineering, and helping organizations turn complex requirements into practical solutions. This podcast is about building AI that earns trust. Every episode will look at the intersection of data privacy and AI, how data is discovered, governed, protected, and used responsibly. We'll tackle challenges like the overlooked role of the data layer, the hidden risks of shadow data, the limits of de-identification, how to balance model performance with privacy, and the trade-offs between building and buying privacy layers for your products. In this first episode, we're talking about the foundation that often determines whether an AI product succeeds or stalls, the data layer. We'll look at why it's overlooked, what happens when privacy is addressed too late, and how engineering it in from day one changes the outcome. So, Mike, why do you think data privacy is the bedrock of responsible AI?
I mean, data privacy is the bedrock of any kind of system development. Understanding your data is kind of key to doing it smart. And the legal, like I said, the laws are they're already going in that direction, and they're going to get a little stricter because people at the end of the day own their data at some level. So, you can't just pretend that somehow that ownership disappears because you owned it, you picked it up. So, and treating your customers' data with responsibly is kind of key. Customers will eventually want to work with companies that do, and probably want to avoid companies that don't.
Right.
And so if you're a company and you want to keep your customers happy, you got to do that. And if you're business to business, it's really the same thing. Because at the end of the day, somebody's going to be concerned about that data, right? If it's personal data, you can't. If you share it, you need their agreement, preferably explicitly. So I guess that's what I would interpret responsible AI. AI is going to just speed things up a lot, but you need to make sure that the AI doesn't have insight into certain pieces of data that you don't have permission to use. It should be obvious, but technology doesn't care. So, and if you don't pay attention, it's in there. Right? Then you have to fix it after the fact, which is probably what will happen. Right? They're going to say,
but that becomes more challenging.
How do we filter? AI, right? How do we filter AIs?
I mean, you have to start over at that point, right? If you want to incorporate data privacy after you've already trained
your AI, could be an idea for a new product.
Yeah, you have to start over.
The AI muzzle.
Responsible and arguably successful AI isn't just about what the model does. It's about how data flows into and through the system and whether that flow respects privacy, consent, and context. So, Mike, what does responsible AI really mean in practice, and why is data privacy central to it?
I think what you're getting to, right, is the idea that you have to train your data. You have to train your AI models using data, and if this data has sensitive information in it, it will leak into the AI model, right?
Right. What's worse is that it could leak into responses from the AI model.
Right.
Right, because the AI model just has all these numeric values and parameters and whatnot, but if you've got real patient information going in to your model to train it, and then someone says, give me an example of what a clinical note looks like, it could have the patient name in there. Right? Because you've used real data to train it. Right. There are situations where obviously you would need to use real data if you're, numbers and that sort of thing, but really being responsible with that is just about, are you are you aware of what data is being sent to the AI, and have you actually de-identified any customer information, patient information if you're healthcare? Are you going to be able to comply with all the regulations?
It's more than being responsible. I mean, you can't have this stuff happen in most cases legally. And you can't.
That's true.
It's true. You hear a lot of the excuses. The model itself just has a bunch of numbers and vectors or whatever, right? Which is true. But to George's point, if it was trained on sensitive data, it can spit it out.
Actually, I read an article recently about some experiment they did with some model where they trained it. They trained one model, basically to ask what its favorite animal is, and it's owl, right? And they took a completely different model that wasn't trained on the same data, but they shared the parameters with it, the numbers and stuff. And when you asked it what its favorite animal was, it turned owl. Right? Because you retrained it to, this is your favorite animal, it's owl. So then some other copy of the model, but with the same parameters, returns that back. What if that was a patient's name?
Right.
Right? That's a problem.
So what are the risks, like, if that does happen, what can be a result to the company?
Well, if you start with, so, before the AI kind of age was upon us, right? The data was considered gold. It was super valuable. Every company was collecting it. So if you start using all that data to train your model, right, and then in your desire to use AI to mine that gold, to actually get a lot of value out of it, you then start using that model you developed on that data in something like a chat app. You just start exposing that model to the general public without recognizing that every query that runs through, as George said, could pop up something that it was trained on. So that becomes a huge liability. So all of a sudden, you've haphazardly hooked up this model that's been trained on, it's been trained on all of your, customer calls, all of your internal resources, but it was also trained on all of your customer data, all of your account data. And you're just having it just respond to whatever this guy asks. And the guy starts to ask, and whoever it is adds something, and the response includes, an account name, an account address, social security number,
Bank account number.
Yeah. Stuff you don't want to get out there.
Some of your billing information in there somehow.
And it's very similar to the same way when databases were first exposed to the internet. The first thing we all did was you put a query in a box, you send that query, you put that inside of an SQL query, you send it to the database, it comes back with a response. People immediately figured out, if this is an SQL query, I can structure my input to be SQL and get back, it's called an SQL injection. So then I get back a bunch of information you didn't want me to have. So from there, we learned there had to be a separation between the database and the input, and you needed filters and checks and protection. And so there's such a mad rush to implement AI at the corporate levels to get money, to save expenses, all the good reasons. That's when people make those kind of mistakes without learning from the past.
Right. Okay. So to that point, if we're talking about what matters most, data privacy issues often start before the single model is trained, especially when organizations have poor data discovery, unclear data provenance, or rely on legacy assumptions about consent. So why is the data layer often the most overlooked part of building AI products, or any product for that matter? And have you seen teams try to fix privacy after the fact, in the late stage? And what happens?
They always try to fix it out. Well,
I think all of our customers have always fixed it after the fact.
yeah.
Right? Now, that could be because some of those customers have been around 100 years, and it wasn't really an issue in 1960 or 1970. But with the advent of everything going online, hacking becoming much more prevalent and attacks becoming much more sophisticated, the meteoric rise in phishing and social engineering to grab somebody's credentials and then log in with a real credentials instead of just trying to break in. All of that has really exposed, what could happen if that sensitive data is not protected in their systems. So, if you think about, because you mentioned consent, right? Yeah. So a lot of companies we work with start with the approach that, okay, I'm a healthcare, and as long as I have a BAA, or it's like a special agreement between the companies to say you're going to protect the sensitive data and not leak it and all that other stuff. As long as I have that in place, I'm good, right? And that's probably true from a legal perspective, but it doesn't mean you're not going to have a breach. It just means that if a breach happens, you can go after someone. The breaches still can happen, right? And I think then companies started to look at, well, I don't want the breach to happen, because then my clients get upset, and then I could lose business or I could get fined, right? And especially then once GDPR came into the picture in Europe, anybody with specific fines around like allowing breaches, then I think it became much more important to fix it. But nobody had really designed their systems that way with data privacy in mind. I mean, now companies should be doing it.
They do it, yeah. Usually they have a process,
and they have some process they're following right now.
But if they're going to AI and they're training it with a bunch of data, they don't necessarily know what's in there.
Right.
Yeah. And you guys have told me that a lot of clients have these massive data lakes where they've just been compiling documents and whatever. And so, to Mike's point, if they're just like hooking that up to the to train a model, they have no idea what's going in there.
Yeah, we used to call them, people used to claim they're building data warehouses, and we used to look at them and say, these are data dumps. Because they just pummel it in there, and they got so much data. And the trick is, there's also kind of this idea of inference data, where if you know this thing and you know that thing, then you could know something else about a person. And that's very hard. It's not intuitive right away. But I think with AI, it's going to get really easy to do that. Really, really easy, right? If I know, if I know where you live and I know your address, I probably know you've ordered this from Amazon. Something silly like that. And I mean, and it can get pretty sophisticated pretty quick. So usually companies focus on the obvious data security things. The inference is something that only some customers are looking at. They usually get to that point down the road, or if they're in that certain types of businesses, or they get burned. I mean, kind of like our former retail customer, or somebody actually did it to them. They took a cash register receipt, they took something else, and they were able to hack into something.
It's crazy. There's so much lost potential there for the company in terms of like financial reputation, just the time lost. It's
time is a big one.
Yeah.
That time's dollars. I mean, time equals money.
How long has it taken to help some of these companies recover or prepare?
Prepare and recover are two different things.
Both. I'm
right?
interested in both.
You want both? Prepare. It depends on how aggressively they want to move. Okay. Some can prepare in weeks. Some take years and can't get things out of the box and put a process in place because they face resistance everywhere.
Internally. Politics. I was working with a client this week who we've been for 3 weeks waiting for approval to put a data de-identification program in place, and they had a candidate application, and they said, oh, well, I talked to the business owner and they're comfortable with us putting production data, so we got an exception. We don't need to do this because the exception path was easier. And we've talked to large financial organizations that had the same problem. Because it took so long to get their de-identification program in place, oftentimes getting an exception and going and requesting InfoSec to approve that is faster and easier than trying to go through the process until they changed it. But that faster and easier, like I've had that in my functions at different companies where it's like it's quicker to just sidestep this, but then down the line you have so many other issues that it's worth the time that you take at the beginning to put.
It can be.
If only everybody thought that way.
Right.
But here's the thing, right? Was any of those functions that you're talking about, did any of those have a real cost of revenue?
It could have, yeah.
Could have. Well,
Yeah, just a little
so
different from
if
this.
you have to wait 3 months to get your product out because you can't get data into test, but if you file an exception and pull production data, you can do it 3 months early. How much extra revenue is that worth? And does it outweigh the cost
Yeah. And the
of
risk.
taking the easy inside step? And that's the problem,
That's the problem.
right? For
Risk reward.
customers that are trying to get products out to market, that competitive advantage of 3 months is huge.
Sure.
And in some cases can more than pay for any, whatever risk might have been there.
Yeah.
But not everybody thinks that way. It depends really on the organization, as Mike said. Sometimes they're like, no, we can't afford it.
Okay.
But those are not the ones that are trying to put a product out 3 months ahead of their competitors. Those are the ones that have a pretty steady state income. They're going to get the money anyway, and they just have to do this
I mean,
because
the trick is to make data security easy, quick.
right.
Right.
I mean, if we
The
make
longer
it
it takes, the worse it is.
yeah, I mean, if it's going to require 27 steps, and then it's going to always be subject to shortcuts
And resistance.
risk reward. Yeah, I
Yeah.
mean, and it's normal. But if we can make it, if we're trying to make, our products are trying to make it easy, quick, and trying to cover the whole process so that you don't. It's unrealistic for people to expect some data analysts to go through 10 terabytes of data and find stuff. I mean, they can be the smartest person in the world, but it's a lot of data.
Right.
It'll take time, a lot of time. So, having tools that can do this quickly, find stuff, figure out how to lock it down, secure it through the whole process, and just, at least, there might be exceptions that you can handle, but if you can get your data, get your product out the door, not have to worry about, am I using secure data? Am I leaking stuff into my AI models? Am I, addressing those issues, I think that's what we're trying to do.
Right. Okay. Now, around de-identification and it not equaling privacy, I've been learning a lot about the various types of de-identification, but you guys are the experts here, so I wanted to talk about just masking data doesn't make the data safe. Without context-aware controls and irreversibility, data can often be re-identified, creating regulatory and ethical risk, even when teams think they're protected. So what are the biggest misconceptions about masking or tokenization in AI pipelines?
I mean, I don't think it's specific to AI pipelines.
No.
Okay.
Right. I mean, so you talked about a lot there, right? You talked about irreversible algorithms. Back in the day, in the early days of quote unquote data masking tools, right, or data de-identification tools, obfuscation, one of the common mechanisms used was, I'm just going to take the last names in the table, I'm going to shuffle them around. So instead of George Barroso, it's George Logan. Super.
Pretty secure.
Yeah, completely insecure.
Nobody could guess that one.
So what was interesting is, and we've seen examples of this over the years across many different clients. We were doing something similar for an investment firm, and they wanted to somehow mask the holdings of their funds, right? So not PII, but they were interested in preventing people that were developing and testing against their databases from seeing what every fund was purchasing and selling on a daily basis, because that's proprietary. Some of that is their proprietary, mechanisms for making money in these funds. And, you're not supposed to release that anyway for like 90 days. That's when the fund holdings can become public. But no company that's doing that wants to share intraday transactions. They consider that highly sensitive. So they had a system they were trying to, how do I prevent people from knowing what this fund is buying and selling? The problem we had there, of course, was a challenge that, if you're buying something else, it has to be a valid stock ticker, right? In these databases, it can't be some made-up letter, bunch of letters, because then it doesn't comply with what the fund is supposed to be buying, right? If you've got a small cap fund, all those tickers should be small businesses, right? Not giant, GE or whatever. And so you had to be careful about how you did it. So one of the things we tried early on, right, when we were first doing this, and probably going back 20 years now, maybe more, was shuffling all those tickers, right? So that, we're just shuffling the tickers, and so that you can't really tell what's being held, but it's all a valid stock ticker still. And, all the appropriate attributes for that fund came along with it. It took about 2 hours for the developer to completely reverse that. One person, 2 hours, in 2005, maybe 20 years ago. No AI, right?
Right.
You didn't need a computer program. Yeah. He figured it out in 2 hours, right? Because of what Mike mentioned, the inference data. Yeah. So, we see products on the market that say, you can shuffle your data and its real value is yeah, but it's completely worthless.
Right.
Because now with computers, it's even faster. It'll take minutes to
2 minutes,
right,
2 hours
to reverse that. So it has to be one way. It has to be done in a way that you can't go back to the original, right? And that gets you some level of security. And okay, we don't have real names. You can't get back to the original. Great. But then what about all the other things that Mike mentioned, inference data? What about all the other little data points that are in other tables that you might not realize? The example he gave about a credit card receipt or a register receipt, we actually encountered that under retail customers as well, where they had masked the database. We asked them what's sensitive and everything else. We went through and masked everything. Everything they said was sensitive, and we didn't say where is it. We said, what do you consider sensitive? They gave us a list of types of data. So we went and we masked all that data in their databases.
That they knew of.
No, well, they didn't even know where it was. We went and found it too, right? But they said, okay, names, addresses, social security numbers, member numbers, customer IDs, dates of birth, address, all of it, right? Everything. We masked all of it. And it took the developer 3 to 4 hours to go figure out which was his record in the table, and then reverse it and go get all of his stuff, all of his masked data, all of those records for all his masked data, and he could still see his entire purchase transactions. All of his transactions were there. Because he figured out, my masked member number is 12345 instead of whatever it was.
Right.
Because he knew he bought something on a particular day in a particular store, and the store number and the register number and the date and time of the transaction wasn't masked. Those were still the originals. So then he said, well, I wonder if I could find somebody else's information. So he went out to social media and found people posting their receipts on social media. So they have a receipt from this particular vendor. Hey, look at this new thing I just bought, and here's the receipt. So he's like, let me look up that receipt number, right? The credit, the store number, the date, and the register number. And he found that record, right? And went and looked and said, okay, this is such and such a person from Facebook, and went and figured out what their mass data looked like, and then was able to reverse their entire purchase history as well. It did it with 3 or 4 different real people that had posted these receipts on Facebook.
Right. So this weaves together their whole life, basically.
Right. I mean, and all they needed was a receipt, a picture of a receipt that was posted on social media.
Right.
To go and get all of their purchase history, right, and see everything they purchased when.
Then we fixed it.
Yeah.
Yeah.
We had to go in and we had to go down to the register number and store number. Once we did that, you could no longer reverse anything. You couldn't find it. You couldn't find the transaction.
Okay.
But that's the point, right? Just because you have the identification tool and you've gone through and you've protected what you think is sensitive doesn't mean that inference data isn't still a risk.
You're better off. You're not. Yeah.
Yeah, it's not going to be as easy, but
right.
I mean, how long will it take an AI to put those pieces together?
Right. Right.
Yeah, they would dig it up.
Especially with the processing power behind it these days.
Well, right, with quantum computing coming up and
Yeah, if that ever becomes a reality
right.
as well. But then all the cryptography will be, then everybody that does encryption is going to be worried.
Yeah, I think it's kind of important to mention. I mean, protecting data isn't about making it impossible. It's about making things difficult.
Right.
Every encryption algorithm to date has been eventually broken. So they're secure. They certainly make it very hard for people to break in. It's going to cost them a lot of money to break in, or to break the algorithms. But it doesn't mean it's impossible. So the idea is really about making it hard enough, or making it so hard that people won't bother attacking that area. I mean, test environments, stuff like that. They aren't the most exposed things in the world. So if you protect them appropriately, they're relatively safe, and you don't have the risk of, your risk is really about internal people. Right?
Internal.
They're not usually available to external. Test environments aren't usually available to external people.
Right.
So you can, I think you can, I mean, there's, all these tools and technologies work pretty well, and if they're applied, it's better that they're, you apply them at least at some level than not at all, because that just makes it too easy. But you shouldn't have the illusion that they're a cure-all. I mean, social engineering is always going to be the biggest problem, and that's people. That's not the technology. But if you can make it so hard that tricking or convincing a developer to go do something they shouldn't do doesn't get you anything, then you're relatively safe. I mean, if the developer's hell bent on stealing stuff, they'll probably figure out some way to steal it. But that's a different animal.
And actually, we had a client that told us, I don't need it to be unbreakable in development. I just need it to be difficult enough that the developer that wants to steal data goes to production where I can track him and I know exactly what he takes and when and what he did with it.
Right.
So he goes to a different system that has more audit logging.
Different
in there
controls.
and controlled so that he can see and detect that sooner. He didn't care about whether he could spend 3 weeks to reverse engineer it or something, for one record in development.
Right.
Because it would, nobody's going to, unless you're really hell-bent, like Mike said, on not getting caught and stealing something, you're not going to spend that time. You're just going to go to production and pull it.
Yeah. Sometimes, data theft at least used to be a crime of opportunity.
Sure.
People don't wake up one day and say, I'm going to steal data. They go to work and they see something and they're like, wow, all this stuff's just sitting here.
Yeah. Yeah.
One day they say, and then
like a laptop sitting in a car with an open window.
Yeah, exactly.
Like,
a bag
okay,
of cash.
I'll take a free laptop. I wasn't planning on stealing anything today, but it's there.
Right.
But I think the key to a lot of this stuff is you have to know where the sensitive data is in your data. It's not 100% of your data. It's usually a small 5% of your data. Is not even. But let's So if you can't find it or you don't know if you don't know what's in there, you risk you could expose it without even knowing.
So data discovery is a first step in order of operations.
Yes.
If you don't know where your sensitive data is, how can you protect it at all?
And there are so many different kinds. Like I think of, my name, my phone number, but
Those are obvious ones.
those are just the obvious ones.
There's
Like,
others, yeah,
There's
and
so
I think that's kind of that's in my mind step one. Know where your sensitive data is, what you have to be concerned about. Then you can figure out the best ways to protect it, and depending on the environment, depending on the risks. I mean, you can. People are very good at making informed decisions, but it's when you don't know, your choices are lock everything down, or lock nothing down and hope it doesn't happen, or there are companies that just say, hey, we're going to get fined, just hope it isn't too much.
Yeah.
We'll pay the fine.
Yeah, we'll pay the fine.
It'll cost me more to try to put a program in
fix
place.
it. Yeah.
So we'll just
That is a very one way to look at it, and I think we should be able to make it easy enough to protect the data so that approach isn't really necessary.
Right. Not everyone can just afford the fine.
Right.
So.
Yeah, you can't just sit there and, well, you can, but you shouldn't.
All right, so if we're talking about consent, control, and ethical boundaries, I know this might be, an opinion-heavy one, but you guys are the experts here, so I'm curious. Responsible AI systems need to be able to enforce consent. Where data is first used during training and output, it requires understanding now just what the data is, but what it's intended for. So what does consent-aware AI look like in practice? Is there a shift that we need to make to have consent for our respective personal data in a world of AI?
I think you're seeing more and more, almost every state has a data privacy law now, and Europe has GDPR. So I think what will happen over time, so 10, 20 years ago, companies, when they got your data, they felt they owned it. It's their data. Even though it's all your name, address, social security number.
But you gave it to them, so
you gave it to
now it's
them,
theirs.
Now it's theirs. Magic. Kind of the Facebook logic. Anything you post is theirs somehow. And now I think the laws are slowly catching up to the fact that a person owns their data, especially in respect to selling your data to somebody else. It's one thing that you give your data to a business partner or somebody you do business with for a transaction, but it's another thing for them to take your data and then somehow sell it and make money on you without you even having anything to say in it. And I think so the laws are catching up to that, and I think as they do, they will probably require, and it'll, the laws don't usually get very technical, but they'll apply to AI just as well. And if you use somebody's data for something like that, they usually have the right to tell you not to use their data anymore, right? I want to be, forgotten, right to be forgotten. I think that's GDPR to speak, and I think it's in some state laws now where you can send the company a letter and say, I want you to get rid of my data from all your systems. And if you do, they have to do it legally. Yeah. Well, the laws, they're starting. I mean, there's already data. I mean, the data privacy laws keep getting updated. So I think if it's a compliance issue, probably, and companies over time will, eventually, 10 years from now, you won't be able to sit there and say, well, it's too hard.
That's not going to be acceptable.
No, it won't be acceptable. I mean, an AI should be able to go find it everywhere.
Yeah.
So, I mean, maybe we'll have police AI.
The AI police.
The AI police bot. Check all your data.
So, to that point though, around like building things and kind of being at the forefront, can privacy as a component of your business be a competitive advantage?
I mean, your customers are going to appreciate it, and some of your customers are going to enforce it. It's usually contractual. Insurance companies require it, right? I mean, if you want insurance, you have to, they're going to ask you 20 questions about how you protect your data. And if you don't do it, they're going to say you got to do it or you no insurance. So that's a simple one. In the financial sector, usually, if a company is a vendor to another company, they are required to protect the data. I mean, companies realize how valuable data is. They're not stupid in that respect.
Sure.
And they know that you got to protect it. So it's really a question about how much effort do you put in, how much money, risk. You're making a business decision at the end of the day.
Do you think it's different? Like if we talk about business to business, that's one thing. Do you think it's where it's business to consumer, it might be a bigger competitive advantage because?
No, it's just the opposite, right?
Yeah.
It's just the opposite. Consumers have been kind of
Don't care.
Well, they care less, and they've been taken advantage of, and they don't realize what they're giving away. And like I said, that's legally, people are starting to realize it, and they're starting to catch up. You know, and
Yeah.
the
Well,
laws are starting to catch up too.
Yeah, and in a B2C environment, right, the customer has so little power and usually represents such low value as far as revenue. Whereas in a B2B, right, those vendors or those partners, right, represent significant revenue, right? So they're going to have an outside say. Like Mike said, that's why they get contracts about saying, no, you're going to protect my stuff.
Okay.
I mean, you're seeing companies, I mean, Apple is a good example. They do make a fairly big push about data privacy for their customers. And I would argue that anybody who's cares about data privacy is probably going to be, receptive to that messaging. Kind of look at and say, okay, am I going to buy an iPhone or am I going to buy an Android phone, and which one's more secure? And if they do the research and they come to that. So I think it does have an impact. But the flip side is, if you want something from a company, you're one customer out of a million, you might just say, oh, screw it, I'll just buy it and give them my phone number.
Right.
I don't want to give them my social security number, but they ask
do
for it, and I want the widget.
Right. Yeah. No, I've certainly done that.
But
So I'm interested in your opinion, though, on if you were to give me your opinions on how data privacy needs to be handled in an age where AI development requires data. What should we be doing differently? What should businesses anticipate, and what steps can we take now to prevent problems down the line?
I don't think they should be doing anything differently than what we've been touting for the last 20 years.
right, they should be doing it.
They should be doing it,
Right.
right? Like,
Right, the need is just
I
increasing.
remember when we first started doing this, Mike, that I thought, okay, 20 years from now, like once all the legacy apps are replaced,
Yeah,
then this security will be built in, and we'll be in a different place, and then we'll be focusing on different things.
right.
But it never came,
No.
right? I don't understand why they wouldn't want to protect data at all layers
Well,
of there.
it's the business thing.
But right. It
Money.
goes back to the money, the
I
cost.
want to get it out before my competitors, so I'm going to skip a few steps.
Yeah.
And security is one of the first ones that goes, because you hope, as long as you don't get caught, you're fine.
Right.
It's like a
If there's no breach,
hourglass.
You don't, you save
Right.
all that money of not having people spend time or whatever to implement the program.
But you notice the companies that get breached, typically the ones that grow real fast, and they get breached.
Right.
It's almost, I mean, somebody should do a study on that, but it's almost systematic. Every time I hear about a new company, 6 months later, they get a breach. Coinbase.
Or, what about the companies that have a breach and then have more? Like the T-Mobile has had multiple breaches.
Yeah.
Right? Some of those came from their development systems.
Yeah, no, these companies, I mean, that's the challenge, right? They want to grow, they want to scale quickly, and they take a lot of shortcuts. And I think what we're trying to do with the products we build is just make it so that you don't have to make a choice of either or. It's not either I grow my business quickly and I have to take shortcuts, or no, you do both. You grow your business quickly and you're not slowed down by security, but you still do security.
Chris, as somebody who's building a product that's designed to build privacy into your AI, into your development, what are your thoughts on some of this?
Specifically on the AI piece, it's a lot of what we've talked about. You've got to, if you're developing your own AI model, right, you've got to, you have these massive data lakes, you've got data stored everywhere. Your people are going to use that data if they have access to it. So it used to be you would just lock it away, but now that everybody's going to be using it, whether it's training a model or feeding it into a model, you've got to ensure that data is protected or masked. For example, like in the rush to kind of take advantage of some advanced AI agent, you start feeding some data from your system to a vendor to their AI. Okay, so the way AI works, right, we talked about like it's just a bunch of numbers. It converts that data into numbers to then feed it to the model to get the response. Does that conversion happen on site at your location, and what's being sent over the wire is numbers? Or are you sending sensitive data across the wire to a third party who then is doing something with it, and then converting it to the embedding. So all of these pieces of the, from the flow from where the data sits and who has access to it, what it's being hooked up to, what it's going into, and then what's coming back from those responses, every one of those things you need to be diligent as far as, is your customer data safe?
So, final thoughts here on where to start. So, responsible AI doesn't just start with the model, it's going to start with the data. Teams who are asking the right privacy questions before building are the ones who will move faster, avoid rework, and earn long-term trust. So, my questions for you are, if you're starting a new AI project today, what should be the first privacy conversations your team has, and what does a good starting point look like?
Well, I mean, the first question is going to be, it's like anytime a large company is dealing with their data, right? Whether it's like, oh, we need to store this somewhere, the question always becomes, what data, where is it, how sensitive is it, right? So there just needs to be checklists before you have people running off doing things. That's the big piece. And then, we talked, one of the things you said was, I forget the exact phrasing, but essentially people who do it first will do it faster, but that's not always true. Because as I think Mike said earlier, if you overprotect things and you make it too difficult, right, you can wind up making it so cumbersome that they just don't do it, or it takes too long, and now your competitors have the advantage. So what you do need is a tool, like ours, that can make that process much simpler, so that you can quickly identify where you're at risk, and then take actions that are very directed, instead of putting everything in a vault and making it difficult, or just letting everything go, right? You've got to be very strategic so that you can, quickly mask or protect the things that you want, and then get on with the project.
Right.
Smart data privacy.
Yeah, to Mike's point, smarter data privacy means, the traditional methods that have been used are proven, to be somewhat effective, but that somewhat gap is growing, right? Especially as data is captured in different ways, in different data sources. Maybe you can write a regex pattern match that will find some of your sensitive data, but maybe not, right? It might be difficult to find that. The example I always use is brown a last name or a color? If you're just looking for brown, like, you have no context without knowing everything else around it as to whether that's being used to describe someone's hair color or eye color, or whether that's someone's last name, right? So you have to look at some of the context in which those words and patterns are being used, and that can tell you whether it's sensitive or not, right? So I think, the discovery process itself needs to evolve, because if you look at what's out there, most of it is still using kind of the old way of doing things, which is match these patterns and then let the user tell me what else is sensitive, which can work to a point, but we'll miss a lot, right? We were doing a POV with a client, and we ran discovery against their schema, and they're like, oh, I know where all my sensitive data is. Here's the list of tables. It's great, but someone had made a backup table during one of the production deployments that was sitting out there that wasn't on a list, that had customer social security numbers in it, customer names and addresses, right? Okay, it was 5 years old, but how many of those customers moved or changed their social security number in the last 5 years? Probably none. So, having that extra table out there that they didn't even realize was there, it needed to be cleaned up. But because it was in production, and they made a copy, and they had their list, they went through their list and did whatever scrambling they did on their list. But that backup table that the DBA made accidentally got pushed into development for the last 5 years.
Wow.
Nobody noticed it. Like, you have to look at everything. You can't just say, oh, I know where it is. You might, but you don't know what else is in the system.
Right.
That may have been created as a backup table during a production deployment. Who knows? Right?
Yeah. And that's even worse with off-the-shelf software. They do their own thing.
Right.
And
If you have no control over it, off-the-shelf software,
or vendor software.
vendor can just
We were talking
create
to
these
a client.
things.
They use a billing system that was built by Accenture or somebody, which is great, but who knows?
Who knows what's in there?
Yeah.
And when they do releases, what they're adding,
Yeah.
what they're tracking, where are they taking customer information and putting it in other tables,
Yeah.
right? That you didn't realize. So you
To
need to
support
have
new
something.
features.
You need to have a process that actually goes through and periodically checks this and makes sure that, oh yeah, okay, there's new tables. I need to check those.
Mhm.
If you can't automatically figure out when there's new tables, like, you're at risk. You won't know.
So is this a case where AI can actually help you with
Yes.
finding these things?
Absolutely.
Of course, yeah.
So
Yeah,
this
because it
is
looks
a-
at the actual data, not just the names and just the context. It looks at the data. So if somebody types it into a notes field or somebody puts it into a comment section, it'll find it.
Right.
It'll find it wherever it is.
Yeah, and that free-form text fields are a bigger problem
Yeah.
because the people can copy and paste anything in there.
Right.
There's no controls in the front end
Right.
because it's supposed to be a miscellaneous text field where you put notes, right? And you can tell people don't do that, but they might do it anyway,
Right.
Yeah.
right? So,
I mean, a lot of these systems is kind of interesting. When I was at a client site, cell phones were a relatively new thing.
Wow.
Yeah. So interesting, the applications didn't really have a place to put cell phone number, right? You had phone number, and you
Yeah.
typically had fax number,
Right.
but you didn't have cell phone number. So they put it somewhere, and then what would happen is that they'd build a new application that relied on cell phones because it sent text or something, right? So that application would copy the data from the old system, and then add the cell phone number as the main driver for the whole application. But they just dragged all the old information along with it. They didn't use it. They didn't use fax number, but they took it,
Right.
right? And then you can imagine they probably took that approach to application upgrades is still pretty common because it's the fastest way to do it. Take something that exists, expand it, update it, enhance it, versus start from scratch, which is expensive. So I think we're going to see this for a while. As George mentioned, these applications don't go away a lot of times.
Right.
I mean, we've had a few clients, their Siebel systems are 20, 30 years old and they're still running.
Right.
It's got all their customer information there.
Okay.
So, interesting challenge.
Great conversation. Thank you for all of the insights. This has been a great start to our conversation on building AI that earns trust. Thanks for joining us for episode 1, Why Data Privacy is the Bedrock of Responsible AI. We hope to see you back for the next episode, The Data Layer of AI, What is Often Overlooked.